Explainer. Today, we're going to talk about three words you probably use every day: work, energy, and power. But here's the thing, in physics, they're not just ideas. They are super precise, connected concepts that literally explain how our world moves. And we're going to break them all down. So let's kick things off with a question for you. Right now, are you doing work? I mean, you might feel like you're working hard, just concentrating on this, but in the world of physics, how hard you feel like you're working, it just doesn't count. Scientific work is all about one thing and one thing only: movement. So here's our game plan. We're going to start with what physicists actually mean by work. Then we'll see how energy is basically the fuel needed to do that work. And finally, we'll look at power, which is all about how fast it all gets done. Okay, section 1. So the first thing you have to do is just forget everything you think you know about the word work. In physics, it has absolutely nothing to do with how much effort you put in, and everything to do with the force causing something to move. And this slide just lays it out perfectly. On the left, you've got stuff that feels like a ton of work: studying, holding a heavy box. But from a physics perspective, nope. So what's the big difference? Well, all the examples on the right have a couple of key ingredients that the ones on the left are totally missing. And here they are. For work to happen, you absolutely need two things: a force, like a push or a pull, and that force has to cause displacement, which is just a fancy word for moving from one spot to another. If you've got one without the other, well, scientifically, you've done zero work. You know, this is the classic physics brain teaser. You could lean against a brick wall with all your might. You'll get tired, you'll break a sweat, you'll feel completely wiped out. But because that wall didn't budge an inch, its displacement was zero. The amount of scientific work you've done is also zero. It's that simple. No movement, no work. Okay, so we've got it. Work needs force and displacement. But there's another layer here. It's not just that you push and it moves. The angle between the direction of your force and the direction of the movement is totally critical. And this is where the math comes in, but don't panic. You don't need to be a math whiz. The really important bit is that cosine of theta part at the end. All that little piece of the formula does is measure how much of your force is actually helping the object move in the direction it's going. So depending on that angle, you get three totally different kinds of work. First, there's positive work. That's when your force and the motion are in the same direction, like gravity pulling that apple down. Then there's zero work. Think about carrying your groceries. Gravity pulls down, but you're moving forward. The force is perpendicular to the motion, so no work is done by gravity. And you can even have negative work, where the force fights against the motion, like friction slowing a box down. All right, now that we've really got a handle on what work is, we can finally talk about energy. Because you see, you really can't have one without the other. Work is the action, and energy, well, energy is the potential to do that action. And that's pretty much it. It's that simple. Energy is just the capacity to do work. If something has energy, it has the stored up ability to apply a force and make something else move. Think of it like the fuel in the tank. And this whole relationship is a two-way street. When you do work on an object, say you lift a box onto a shelf, you increase its energy. You're basically charging it up. And on the flip side, when an object does work, it's spending or using up its energy. And since they're basically two sides of the same coin, it makes total sense that they share the exact same unit of measurement. We call it the joule. Okay, so let's recap. We have the action, that's work. We have the potential for that action, that's energy. So what's the last piece of the puzzle? It's power. And power is all about how fast things happen. Yeah, power is simply the rate at which you get work done. It isn't just about how much work you do, it's about how quickly you can do it. So if you do the same amount of work but in less time, you are, by definition, more powerful. So just look at this. Person A and person B, they both get the exact same amount of work done, 10 joules. But check out the time. Person A does it in 5 seconds, while it takes person B 10 seconds. That means person A is literally twice as powerful. And the unit for power is the watt. You've definitely seen this on light bulbs and appliances. It's named after the inventor James Watt, and 1 watt simply means 1 joule of work is being done every single second. Okay, let's tie all of this together now with a big real-world example. Picture this. A massive crane lifting a car straight up into the air. Let's see how work, energy, and power all play a role here. So here's the breakdown.
First, the crane has to generate enough force to beat gravity and lift the car's weight. That's 4,900 newtons. Then, by lifting it 4 meters, it does work on the car, a whopping 19,600 joules. And finally, the power of the crane's engine is just that work divided by how long it took. If it did all that in 10 seconds, its power is 1,960 watts.
So if there's one really important thing to remember from all this, it's this right here. Work and energy are about amounts. They're quantities of something. Power? Power's the odd one out. It's a rate. It's the only one of the three that really cares about the clock. And that leaves us with this one last, kind of mind-blowing thought. We're told that energy can't be created or destroyed, right? So when you do work on